One of the ways to solve any sort of equation is you shift all the terms of the equation on one side, make the other side of the equation equals to 0, and then you factorize the expression. Alright, so if you guys are struggling or you guys always struggle on how to factorize the expression, this video will be for you guys. So there are certain steps that we have to follow for factorization of algebraic expression or factorization of a complex equation. Okay, the first step is always to take out the common term. Now, while taking out the common term, you always first look at the sign, the coefficient, and then the variable. We'll talk about it in more detail. Let's jump on to step number 2. Step number 2 is you apply the identity a square minus b square. That is equivalent to a plus b times a minus b. Now, this second step will always be applicable when there are only two terms involved. That's what I've written over here. And secondly, those two terms are both perfect squares. Now, what are perfect squares? Perfect squares are the terms that are obtained by multiplying a number or a term by itself, right? Like 25, we do know it's a perfect square because 5 square is 25. X square, it's a perfect square because it is obtained by multiplying x by x itself, right? So any term that is obtained by multiplying any term by itself is known as the perfect square. So step number 2 is only applicable whenever we do have only two terms involved and both should be perfect squares. Again, we will talk about it in more detail in this video when we will do the example. The third step is middle term break. Now this step over here is only applicable in case of three terms. Okay, whenever three terms are involved, then we will apply this step. Now in this video, we will do a few more examples of factorization of two terms only, and in the second part of this video series, we will talk about the factorization of three terms. All right, now let's jump onto it and have a look at how will we actually factorize two terms. Now in this example number 1, have a look here. We do have two terms involved, 1 and 2. Now always remember the term contains three things, right? The first one is sign, second one is coefficient, and the third one is variable, and then the exponent of the variable as well. Okay, so whenever you are taking out the common term, that was the first step of factorization, you will always have a look at the sign, then the coefficient, and then the variable. Always follow these steps. All right, now in order to take out the common term, let's have a look at the coefficient first. So for the coefficient, you'll think about the maximum number that is divisible by both of the numbers. Okay, if you are factorizing three terms, then you will look out for the maximum number that is divisible by all of those three terms. All right, but if you are talking about factorization of two terms, which we are doing right now, we will look for the maximum numbers that is divisible by these two numbers. So what is the maximum number that is divisible by 3 and 9? That is 3. Okay, with the variable, we will talk about the variable that both of the terms have, one thing. Secondly, we should look out for the maximum power of the variable that both of the terms have, or in case if those are three terms, then maximum power of the variable that all of those three terms have. Okay, let's apply this over here. Now I can see this term contains x, but this one do not have x. That means there won't be any variable as common in this one. So let's put in the bracket. Inside the bracket, we will divide the terms by this number that we have taken out as common. So 3 by 3 is 1, x was inside, so x remaining, plus 9 divided by 3 is 3. So this is the final answer for the factorization of this expression. Okay, let's jump on to example number 2. Again, we will apply the first step, that was take out the common term. Now in this one, I'll first have a look at the coefficient. So this one has a coefficient of 1 and this is a coefficient of 25. Even if I take out 1 as common, it won't make much of a difference. It's gonna stay the same. So let's jump onto the variable. I can see this term has the variable x involved, but this term do not have any variable. That means there is nothing as common in these two terms. Let's jump on to the step number 2. Step number 2 said that we have to apply the identity a square minus b square. I'm gonna write it down over here as well. And that was equal to a plus b times a minus b. But the condition for this identity was both of them needs to be perfect square. Now whenever you are thinking about that if the term is perfect square or not, let's see how will we actually think about it. So I'm going to think about x square is the square of which term? That is, if I take the square of x. And 25 is the square of which term? That is 5 square. Now if you are at a beginner level, like you are learning it for the first time, after doing this step, I will always suggest that write down the values of a and b for yourself. So just compare these two expressions. See, square is involved, and then the square of the term, like the first term, that first term is basically a, and then the second term is b, on which there is a square being applied, right? So that means this one, x is a in this case, and the second term, that is 5, that is equivalent to b. And we can see it over here, a square minus b square is equals to a plus b times a minus b. Now let's replace these values of a and b into this formula. So a square minus b square is equivalent to a, that is x, plus b times a minus b. So that is the final answer. Let's jump on to the example number 3. Again, first have a look at the common term. So we'll first look at the coefficients. Maximum number that is divisible by both of these is 2. Have a look at the variable. Now this has x, but this term do not have x. So I'm not gonna take any variable as common, and I will be left with the first term will be, we will divide this by 2, it's gonna be x squared minus 18 divided by 2 is 9. So we have applied the first step. The second step was, again, we will look out for the identity, and that identity is only applicable in case of two terms. We do have two terms, but we have to look if these both of the terms are perfect squares or not. So x square is the square of x, and 9 is the square of 3. From here I get to know, okay, the value of a is x, you can see it over here, and the value of b inside the bracket, that is 3, right? And remember, a square minus b square was equals to a plus b times a minus b, right? So this would be equivalent to, I'm going to replace the values of a and b with x and 3 now. So this would be equivalent to a plus b times a minus b. And that's it. We've got the final answer. Let's jump on to the example number 4. This looks a bit tricky one, but let's have a look. Again, think about the maximum number that is common in both of these numbers. So 18 and 50, maximum number that is divisible by both of these numbers is 2. So I'm going to take 2 as common. With the variable, I can see that this has m but this one do not have m, right? That means there is no variable as common in these two expressions, in these two terms. So the terms inside the bracket would be 18 divided by 2 is 9, m to the power of 4 minus 50 divided by 2 is 25, x square y to the power of 4. Okay, let's jump on to step number 2. Step number 2 was, we'll think about that if there are perfect squares involved, we will see a square minus b square equals to a plus b times a minus b, if that identity is applicable or not. So in order to check that, the way to determine that is, we will think about 9 is the square of which number? That is 3. m to the power of 4 is the square of what variable? That would be m square, right? Put a whole square minus 25 is the square of which number? That is 5. X square is the square of which variable? It is x. And y to the power 4 is the square of which variable? That is y square. Put a whole square on it and close the bracket. So again, remember the identity, a square minus b square is equivalent to a plus b times a minus b. That means a in this case is 3m square and b in this case is equivalent to 5xy square. Okay, and that is equivalent to, like, a square minus b square was equals to a plus b times a minus b. So the final answer would be 2 times a, that is 3m square, plus 5xy square, and then a minus b, that means 3m square minus 5xy square. And that is the final answer. Now let's have a look at this example number 5. Remember this a square minus b square equals to a plus b times a minus b. We've studied that that will be applicable whenever there are two terms involved, right? Now that identity can also be applicable whenever the expressions are involved but that are in the form of a square minus b square. Okay, let's have a look at this example. See over here, I can see if this whole expression is a and this whole expression is b, then that would be a square minus b square, right? So let's just apply the same concept over here. So a square minus b square is equivalent to a plus b times a minus b. Alright, so let me just do one thing. I'm gonna use the square bracket here and then a round bracket inside the brackets. Now why I've used the round bracket? Because minus will be multiplied by both of the terms, right, over here. So either you can multiply it directly or you can put a round bracket here and then now I'm gonna simplify it. But make sure you're factorizing it, so you have to stay within the brackets, okay? So I can see like terms here, 3x plus 4x, that would be 7x, and minus 2y minus y would be minus 3y, times again 3x minus 4x would be minus x, and minus 2y plus y would be minus y. So that is the final answer. So again, this is how you factorize the two terms. Alright, there were only two steps for factorization of two terms. First one, you take out the common term. Alright, now in order to take out the common term, first look out for the sign. then the coefficient, and for the coefficient you will look out for the maximum number that is divisible by all of those terms involved. Okay, and the third was variable. Now for the variable, you will look out for the common variable, but the maximum power of the variable that is common in both of the terms, or if there are three terms involved, then the maximum power of the variable that is common in all of those three terms. Okay, and then once that first step is done, you will look out for the identity, that is a square minus b square equals to a plus b times a minus b, and we'll check out if that identity is applicable or not. And when would that be applicable? Whenever there are two perfect squares involved. Alright, I hope this video clarifies on how to factorize the expressions. In the next video, we will talk about the factorization of three terms as well. So stay tuned, and I'll see you guys in the next video.